You know, a revolution is quietly taking shape across Vietnam's cityscapes. It promises to change not just how we build, but what we build with. We're going to dive into a groundbreaking shift in the construction industry, one that's moving away from the old ways and embracing a material that is somehow both ancient and incredibly futuristic: timber.
So at the very heart of this whole revolution is one simple but really powerful idea. For over a century, our go-to building materials, I'm talking concrete and steel, have produced enormous amounts of carbon. Well, modern engineered timber does the exact opposite. It literally takes carbon out of the atmosphere and locks it away for the entire life of the building. I mean, this isn't just a small improvement, it's a total reversal.
And look, this isn't just some environmental pipe dream. It's a serious economic strategy. The Vietnamese government has set a really ambitious target to build a $6 billion domestic market for timber products by 2030. That's a huge signal that the future of construction here is tied to this incredible material.
Okay, let's get into it. First, we'll look at the net zero challenge, then see why timber is such a smart solution. We'll tackle those big questions about strength and safety, break down the financial wins, understand its role as a truly circular material, and finally, look ahead to what this all means for Vietnam's green future.
So first up, why is this massive change happening right now? Well, it all kicks off with a major national commitment. Vietnam has pledged to hit net zero emissions by 2050, and that puts one industry in particular directly in the spotlight.
The construction sector, as you probably know, is a huge source of emissions all over the world. So to hit that 2050 goal, the industry can't just make a few small tweaks here and there. Nope, it needs to fundamentally rethink its materials and its methods. The pressure to decarbonize is just immense, which is creating this powerful demand for a totally new way of building.
And that brings us to the hero of our story. Now, this is not the timber you're thinking of from old log cabins. Not at all. We're talking about highly sophisticated, engineered wood products, EWPs, designed specifically for modern, large-scale construction.
These are materials like cross-laminated timber, or CLT, and glued laminated timber, which you might know as glulam. See, by layering and bonding wood in really specific ways, like crisscrossing layers for CLT, we can create structural parts that are incredibly strong, very consistent, and way lighter than steel. And you gotta remember, every single piece is basically a block of stored carbon.
All right, so how does this actually perform on a construction site? Because for any developer, any engineer, or, any building association, the first questions are always going to be about strength and safety. So let's just tackle those concerns head on.
This is the most common question, and it's a fair one, right? We've been taught to associate strength with heavy things like concrete and steel. So how does wood really stack up?
Well, the answer is surprisingly well. Timber has this incredible strength-to-weight ratio. This quote from an industry expert really captures what's possible. Because it's so much lighter than steel or concrete, you can actually add floors to existing buildings, or just build taller on new sites without needing these massive, super costly foundations. And this number, it just illustrates that point perfectly. On sites with poor soil conditions, a lighter timber structure can require up to 50% fewer foundation piles than a similar building made of concrete or steel. I mean, that is a massive saving in time, cost, and complexity, right from the get-go. Okay, this is the other big one, and it's totally understandable. The whole idea of a wooden skyscraper can sound a little risky, but the science of how mass timber behaves in a fire is honestly fascinating and pretty counterintuitive.
So unlike steel, which can buckle and fail pretty suddenly at high temperatures, mass timber performs very predictably. When it's exposed to fire, the outer layer burns at a slow, known rate, and it forms this layer of char. Now, this char acts like a natural insulator, protecting the structural wood underneath for a really long time, which gives people plenty of time to evacuate safely.
Okay, performance and safety are absolutely crucial, but for any of this to be adopted at scale, it has to make financial sense. So let's talk about the bottom line, because the business case for timber is incredibly compelling. This right here is a game-changing number for any project developer. Timber construction can be over 30% faster than traditional methods, and faster builds mean shorter loan periods, less debt, and getting your units on the market sooner to start generating revenue. It's a direct path to a much healthier project budget.
And the financial benefits don't just stop when the construction ends. In established markets like the US and the UK, we're seeing that timber buildings command higher sales, resale, and leasing values, often by 10 to 20%. People are actually willing to pay a premium for the look, the feel, and the sustainability of these green-focused buildings.
But, and this is important, unlocking these financial benefits means you have to fundamentally shift how you manage the project. You can't just take a concrete design and build it with wood. The key is what's called a design-first model. You spend maybe 70% of the project time in meticulous design and planning. This makes the actual on-site assembly incredibly fast and efficient, taking up only 30% of the time.
We've talked about storing carbon, which is a huge environmental win. But engineered timber takes sustainability even a step further. It's a key player in what we call the circular economy.
So what is the circular economy? Well, in a nutshell, it's a model that aims to eliminate waste completely. In building, this means we stop thinking about demolition and start thinking about deconstruction. We design buildings today so that their parts can be easily taken apart and reused in the future.
And this is where timber just excels. The components are precision-made in a factory. Then they're brought to the site and assembled, often with just screws. So at the end of the building's life, you can simply reverse the process, unscrew the components, and boom, they're ready to be reused in another building, continuing to store that carbon for another generation.
And to put a hard number on that climate benefit, detailed life cycle assessments show that every single cubic meter of construction-grade timber stores about 718 kilograms of CO2. When you start multiplying that by the scale of a multi-story building, the positive impact is just staggering. So let's bring all of this together. We've seen a really powerful solution to a huge national challenge. And this isn't just about being green. It's about building in a way that is fundamentally better, faster, and more valuable. The timber advantage is crystal clear. It's smarter, using that design-first approach to speed up construction and boost efficiency. It's greener, actively storing carbon and fitting perfectly into a circular economy. And it's stronger and safer, totally debunking old myths with modern engineering and predictable performance.
This timber revolution isn't some distant possibility. It is happening right now, driven by national policy and very clear financial incentives. So for the developers, the architects, and the building associations all across Vietnam, the question is no longer if this is the future, but how is your next project going to be a part of it?